anyone practiced the session yesterday? Two concepts: email notification and as well as master and slave concept. If any questions, we can discuss and continue further. Vishal, Muhammad, Rutaja, Surya. Hello. Please respond, guys.
No one practiced.
I think no one practiced it.
Yes,
Okay.
Ravi.
So, okay, problem. So please make sure, guys. I told you right yesterday. So please make sure, huh? So let's start talk about Docker. So Docker concept. Okay. So Docker is a containerization tool. See what is a Docker? So Docker is an open source containerization platform that allow developers to package applications and their dependencies into a standard units called containers. Containers are isolated from each other and bundle their own softwares, libraries, and configuration files. They communicate through well-defined channels. That means the containers are isolated from each other to bundle their own softwares. For example, in our Docker image, you can define your own softwares, own libraries, own configuration files to communicate there. Okay. So what is happening before Docker? What is happening now Docker? So we'll talk about. Okay. We'll explain later clearly about what is Docker, what is Docker works, what is Docker file, what is Docker use case. Everything we will explain. But with before Docker, how it is working. Before Docker, there are two approaches. One is physical server approach.
Are you
And
sharing your screen?
sorry, I haven't shared. Sorry. Able to see my
Yeah,
screen?
no, yeah, now it's visible.
Physical server approach, virtual server approach, virtual server approach. So before Docker, what is happening? So before Docker, we have these two kind of. First is physical server approach. Another one is virtual server approach. So what is physical server approach and what is the advantage and disadvantages? What is virtual server approach and what is advantage and disadvantages? So for physical server approach, let's take an example. Let's take an diagram. Okay. So what is the difference between what is the difference between virtual server, physical server approach and virtual server approach? Anyone knows the generic term? What is physical and what is virtual?
A physical is nothing but if, for example, if there is a full hardware of server, we use that directly. And coming to the virtual, we divide it virtual into two parts and use it.
So that means in a technical term, so in our laptop is physical or virtual?
A laptop will be physical.
Yes. So virtual in the sense you are creating your AWS servers in somewhere like Mumbai location, some other regions, right? Or those are virtuals. So you can't touch, you can't see those servers, right? Just we are using it. The best example. Clear? Virtual in the sense it is stored in some other location and we can use it. So physical in the sense we can see and we can touch it. So
Can we also say that virtual is something which is hosted in the web and
yes,
physical which is hosted in the data center, physical data center?
yes, yes, that is true. So if we go to here, hardware, RAM, CPU, memory, everything will come under this, and this is operating system. Operating system can be Linux, CentOS, Ubuntu, Red Hat, anything. That can be anything. And this is application server, like application server, like Tomcat or JBoss, something like that. So this is your application. This is your application. Example, a student bar file application. For example, what we discussed, right? student application, student project. Okay, so if you go to physical server approach, for physical server approach, we will take one hardware and hardware. On top of that, we will install OS like CentOS, something, whatever the OS we have. We will install on top of one OS. Uh, on top of OS, we will be installing one application like Tomcat, WebLogic, JBoss, anything. So and also we will install some libraries like whatever the libraries are required, right? So for your application, we have to install that as well. So once application is deployed, we will access the application using some HTTP URL and then that you know, right? So we have created one AWS server. On top of that, we have installed some we have installed one of the Ubuntu server. On top of that, we have installed Tomcat application server. On top of that, we have installed one of the WAR file deployed. Did you remember that? Did you remember? Hello?
Yeah, yes, Ravindra.
So that we did it, right? Like we have we took one hardware and CPU memory. On top of that, we have selected one operating system. Once the operating system is ready, we have installed one of the application server, that is Tomcat. On top of that, we have deployed one of the student WAR project from Google. We downloaded and we deployed and we access the web UI with HTTP link with public IP address, right? So that is where I'm explaining it actually. So once the application is deployed, we will access the application with HTTP URL, HTTP and then URL and then port and then application name, whatever the application we have deployed. So if you are changing if you are changing the application or feature, for that we will stop the application, remove the existing app and deploy new one, right? That is what we have to do it, right? Hello. So if you want to deploy new application in the same server, what you can do? We have to stop your existing application and delete it and deploy the new application, right? If you are if you are making any changes on the application, new feature or new changes that included in the new WAR file, that in that case we have to stop your application, delete your application and then redeploy the application, right? So for example, yeah, so for example, if you are getting more traffic, so this application is accessed by some other peoples, but we are getting less people are accessing, but that time you don't see any issues or any traffic issues. If you are getting more traffic, it can be more critical, right? If you are getting more traffic, it can be more critical. And if your application is disturbed and you need to do same setup on the same server, you have to follow the same approach, right? Like create one hardware and memory and other Linux server, one another application server, and then deploy your application. This will take more time, right? If you want to bring the one more application in some other setup, right? So I want to do same setup in another laptop, another server. What I can do? If it takes, if the setup takes 30 minutes, if we want to do it 10 servers, how much time it will take? It will take more than 10 servers in the 3 hours, right? So like that, you will be getting a trouble or you will lose your access from the customers to access this application, right? Clear? Physical server approach I am explaining it, guys. One app server, one application server can run on one VM only. So you can't deploy or you can't use multiple applications in the one server if you go with the physical server approach. The disadvantages is cost is very high, less scalability, maintenance is very high, and less resource optimization. So if you talk about disadvantages, cost is very high. That means we are increasing the servers count as more. So by default, cost is also high, right? So if the physical server setup is taking $10, if you go with the 10 servers, it can be $100, right? So that means obviously you are increasing your server cost, right? So less scalability. Less scalability means very difficult to scale your application if you're getting more traffic. If the current server is slow, or if you are getting more traffic, it is very difficult to scale your application. That means you can't able to increase the server automatically if the application, if the load is getting more, if the traffic is more to the respective application. So maintenance is very high. That means you have one physical server setup in our one of the area. So if you are increasing day by day more servers, how can you optimize your resource? You need to buy some other space also, right? If day by day you are increasing it, that means very less resource optimization. Like the space also. I mean, if for example your application is 116 GB or 1 TB, but your application is running on just only 10 GB, remaining 6 GB is wasted, right? We can't reuse the remaining space for the other application, other purpose, right?
Yes, sir, simply pasted.
Sorry? Yeah, simply it is wasted. So that is what in physical server approach. Any questions, guys? Any questions, guys?
Ravi, how many levels of storage we are taking in containers on the virtual machine?
Sorry?
Like here, how many levels of storage we are taking, and when it comes to virtual machine, how many levels of storage we need to consider?
Storage.
Yes, that means this OS Linux needs some storage, and application server needs some storage
No,
like that.
not the storage. It will be it is kernel related things actually. It will be so whenever you are creating the VM, right? You will give some bootable files to some GB, right? The same size like 200 MB. We are giving bootable files. OS will use a little 1 GB or 2 GB like that one. It won't use much space, much storage.
Okay.
So coming to virtual server approach, we will give one hardware and CPU, memory, everything will be the same. So here we will install host OS. That means any of the OS, Linux or something, whatever the OS you are going to be installed. Here we will install hypervisor. So on top of that, we will deploy multiple applications. This can be
Do we need to
one.
install hypervisor, or it will available already?
It will. If you go with the virtual server approach, right? Automatically it will come. App 3. See. So in virtual server, we will take one hardware. On top of that, we will install host OS. On host OS, we will install hypervisor. Okay. So hypervisor, on top of hypervisor, we will install guest OS. Sorry, here it will be guest OS. Guest OS. On top of hypervisor, we will install guest OS. So guest OS will use the application. That means guest OS is nothing but, so whenever we are creating the Docker image, right? We will use one base OS to build the Docker image. The Docker image will use the guest OS, whatever the OS we are bundling with the Docker file. That means you have 3 images, Docker images. 3 Docker images as used by 3 different operating systems. So you can deploy 3 Docker images on top of hypervisor. So this app 1 is using Linux OS, app 2 is using Ubuntu OS, app 3 using Debian OS or CentOS. So that means individual apps can use their individual guest OSs. So that means here cost is less. Okay, and scalability, you can easily build your application, and resource utilization also high. That means your application using 16 GB, your VM is having 500 GB or 50 MB, 50 GB. One application will use 10 GB. Another application we can reutilize the remaining space 5 GB or 10 GB. Remaining also we can use. Like that we can reutilize the resource also.
Sorry, repeat once again.
So here we will install one guest as like it is a physical server approach only, but only here the difference is hypervisor we will install. So this hypervisor will help you to scale the application with guest OS. So for example, I have 3 Docker images. My application is running on. I have 3 applications. Each application is running on different OS. One is Linux, one is Red Hat, another one is Ubuntu, another one is CentOS. So I can deploy my 3 different kind of guest OS applications or 3 different kind of applications with the different OSs. I can deploy it here and I can use the I can use this application using HTTPS link, and I can access this application. So in this approach, cost is very less. That means you don't want to do the same setup in some another server. If you want to make it as a same setup, you can utilize the application guest OS, right? Here you don't want to spin your application, you don't want to spin your complete setup into one of the VM variation to spin another application, right? Here guest OS concept, and scalability also high, and resource utilization also high. Maintenance also it will go to more. So for example, let's talk about uh, best example. We will understand physical and server approach.
Ravi, here we are not using the resources efficiently, right? So the cost will be high, no?
No,
We want
resource
to know.
utilization we are using, right? We have three application guest OS running. Your hypervisor is running on three guest OS, so you can utilize your RAM size and all to the different application, remaining application, right? Remaining size, right? So my first application is using 10 GB, so remaining 40 GB still available. I can utilize the remaining 40 GB to remaining application.
You need to increase the
House construction, some everything, whatever the things we did it for the independent house or individual house, same setup you have to do it some other place also, right? The place is different, but the way of construction, the way of building is everything is same, right? To make it as it is. That means cost is high, and we can't utilize the resource, right? Here, if you have one more person needs to stay, you can't utilize here, right? So if you go with apartment, initially you joined in apartment with two peoples. Later on, you later on got increased to five peoples. You can easily move on to some other in the same location, same place. You can easily move on to the uh, you can easily switch to the some other house, right? In the same apartment, there is no extra construction in the same location, same apartment, but uh, house is different, right? Getting me?
sorry.
You are able to understand this difference. I can able to instead of in apartment, instead of creating same setup in another place, I can easily move to the entire remaining peoples into the simply into the same apartment to some other house, right? Easily. So I can utilize the resource in the same apartment, right? So not like new constructions, everything will be new, and I have to get some time to develop this application, something like that, right? Not like that, right? You can simply switch to the some other house, and you can start your things, right? Whatever we need.
This one is container example, this apartment.
Yes. Physical server is individual house, virtual server is apartment. Clear, right? In apartment case, you don't need to build, you don't need to do the setup completely, right? You have already that setup. You can simply switch to the some other house, right? The apartment. In the individual case, in physical server approach, you have to do the setup, and then only you can switch to the another house. That is time taken, cost is high. We need to do complete setup. In apartment, we no need to do the setup. We have already done the setup. Simply you have to switch to the another house. That means simply you have to build your application or deploy your application on the existing VM in a virtual server approach.
Here
Clear?
container simply means whatever the dependencies we need, what are the required, those only we will take here.
Yes, correct.
But Arish is talking about virtualization only. He didn't come to this container concept now.
No, not to come to the container concept. I'm just talking about physical and virtual. Physical and virtual concept only. Container will be the different. These two issues will overcome.
Okay.
So, in an independent house and apartment, for example, if you go to physical server and virtual server approach, scalability is bad. I mean, not good. Virtual, it is average. Resource optimization is physical server, it is very bad. That means we can't reuse. Virtual is average. Cost is also very high. In virtual, little bit better than physical. And reliability also not good in physical server approach. Virtual is average. Whatever the, issues and advantage and disadvantages we have in physical and virtual server, right? Those we can overcome in containerization flavor. Okay. So coming to Coming to containerization flavor. We will, as hardware we will install, CPU we will install, RAM we will install. We will configure. Once that is done, we'll install operating system. That can be anything, Red Hat or CentOS, Ubuntu, anything, doesn't matter. And then we will go with Docker engine. We will install on top of OS. We will install Docker service, that is called Docker engine. Okay. So once that is installed, we will deploy our container. See here, what is the difference? See, we no need to worry on the dependencies, libraries. We no need to worry. Our Docker engine will take care of everything, and the Docker file will take care of everything. So this means each one is one application. This is one application. This is another application. This is another application. You can build your application, or you can deploy your many applications as per your RAM size and usage. Okay. This means one hardware CPU memory we will configure. One Red Hat OS we will select. On top of that, we will install Docker engine, and on top of that, simply we will install our Docker images. So we no need to worry on the libraries or whatever the dependency is required. So our Docker file will take care of all the dependencies. So just we are using the host OS as like a platform. On top of that, we will install all our Docker images or Docker containers to scale your application. So for example, I have 1, 2, 3, 4, 5, 6, 5 applications. So I want to make the same application, whatever the application is running with one. For example, this is student var file. So I want to make it same into the same image, same host. I can deploy easily the same mission with the same application with a different name, different container name. Image will be the same, but container will be the different. In containerization, there is no hypervisor, there is no guest OS like virtual. In physical, we have hypervisor. In virtual, we have guest OS. In containerization, there is no guest OS, there is no hypervisor. So in container, there is no resource blocking to use the containers, are free to use complete resource, whatever the hardware it is required. So for example, you have more traffic in one of the application. This application is having more traffic. You can simply deploy your application within 1 minute. Your application will be up and running in another name. So performance is very high. So it is a lightweight container. The main advantages of in containerization is it is a portable, means we build the image, and use anywhere, anytime, any application. Simply we can say build and shift.
Yeah.
Harish?
Hello?
Yeah.
Yes, you are audible.
Yeah, sorry. Simply we can say build and shift and run the image. Okay. So this is the
Ravi, why it is lightweight?
we can lightweight in the sense if you have Docker image. Okay.
Yeah.
Harish, if you have Docker image, you can use anywhere. That means lightweight. There is no dependency issues. There is no restrictions to use this OS only. There is no restrictions to use this operating system like that. It is a lightweight. We can use anywhere.
Is it compatible to everyone?
Yes, correct. It is compatible. It is not independent. It is dependent. It is independent, not dependent. Dependent on OS. It is independent. See, this is the Docker architecture. Okay. Able to see my screen?
Yes.
So this is client. Docker will work on client server architecture. Okay. So this is a client. This is a Docker host. This is a registry. So Docker build, Docker pull, Docker run. This will be run on one of the VM, and whatever the commands we will enter into the host, right? Those will be go to Docker daemon. Docker daemon will communicate to the client, Docker client. That means which command you have ran, what needs to be execute, and what is the output you have to give. This Docker daemon will help you to execute your commands. So Docker registry, in the sense, we are going to store our Docker images on one of the registry.
Which registry we used mostly in real time?
Docker Hub registry, Docker Hub registry. But in a real time, they will use their own also. Harbor. On my case, I am using Harbor. That is one of the private repository. So we will use it. See, Docker client, Docker host, registry. So these are all the containers. So how to create a Docker Hub account? So Docker Hub account. It is kind of Gmail account creation. How you guys created the Gmail account and how you guys created the GitHub account, like that, right? Like that same only. So go to Docker Hub account creation. Create your account. Let me. See, already I have an account, sign in. If not, use your name. I have already account. So what we can do, right, with Docker Hub, right? So we have the build mission. That means this is your application build VM. I mean, where we are building the Docker images. This is your VM. This is your build Docker build mission, Docker build VM, Docker images build mission, Docker images build VM, and this is your Docker Hub. Hello, I'm able to hear me, right? Docker Hub repository.
Yes, sir.
Docker Hub repository. This is your application server where you can deploy your Docker images. So what we can do right here, we can write some instructions in the Docker file. With the help of Docker file, here we will create Docker images. Here we will create Docker images, and with the help of Docker file, using Docker build command. So once the images are ready, we will deploy, or we will upload Docker images into Docker Hub, that is to this location. So here, whatever the images we have created, right, those images will be stored in here. Like for example, student image name, like student image name version v1, or else like DevOps v2, Linux v3, something like that. So we will maintain some versions. So based on this, we will maintain. So we will push the images, or we will upload the images into Docker repository once this is crashed. So we will simply we will pull the images into the application server. I mean application server in the sense where we can deploy the application server. So here Docker pull or Docker login, username, password. We will log into the respective Docker Hub repository, and we will do Docker pull image name version v4. For example, if I do DevOps v2, so it will automatically download the image from the Docker Hub. It is not depends upon the Docker build mission VM. So now the images are available in this Docker Hub repository. So we will simply download or pull from the Docker Hub repository and deploy the application. So for example, you know the credentials about, that's what I told you, lightweight images, right? So you know the Docker Hub repository credentials. So I know I have one VM. So I have to deploy your application into my VM. How can I do that? I don't want to do any setup. Just simply, if I deploy your image, I want to access your application. So what I can do, I can create one VM. So on top of that, I can do Docker login and Docker pull and Docker start. So it will automatically start your application and access your web UI.
Repeat the process once again.
So we will install Docker. I told you, right? Docker engine we will install, right, on the one of the VM. So that is called Docker. So once the Docker engine is installed, we will do the Docker related libraries, install the Docker related libraries that will be treated as a Docker build mission. So where we are creating the Docker images, that is called Docker build mission. So we will create the Docker images, and once the Docker images are ready, we will upload the images into one of the Docker Hub repository, that is private repository. I mean public repository that is maintained by the Docker. So we will create one account. With the help of that account, we will push the images into Docker Hub. So with the help of Docker Hub, we will pull the images into one of the application server to deploy your application or test your application, your changes. This is flow will happen in a real-time case. Create the images, push it to the Docker Hub or any of the private repository, and pull the images into one of the application server and deploy the application, deploy the image and test your application. If this crashes, you no need to worry. The images are available in Docker Hub. You can simply scale your application or build your test your application. So tomorrow we will talk about how to install Docker engine and how to install the libraries and what is the use of architecture, the architecture we have, right? What is Docker daemon, Docker client, Docker, what the each one will do. We will explain clearly Docker architecture. What is Docker client will do, what is Docker daemon will do, Docker hub will do, all the things we will explain.
Are you using any private registry?
Not now.
Instead of
We will use Docker Hub. Now class for the practice purpose we are using Docker Hub only. So if you want to, you can host one of the private repo. That will be lengthy process actually. We have to do some security level enablements, everything we have to do. But in a real-time case, they will use their own repositories called Harbor repositories, some SUSE repositories, like that they can use.
Those all are private registry.
Private registries.
Okay.
Okay, at least tomorrow class, make sure the email notification and some master and slave concept, please be prepared at least. Okay.
For me, it is impossible, right? Because I need to clear a CSV topic.
Others I'm talking about others. Okay. Okay, guys. Thank you.
Thank you, Ravindra.
Thanks, sir.